All right, so this meeting is now being recorded. The chat, I believe, will not be recorded and put up on YouTube. So we will talk about that as we get there. So welcome to the Python Education Summit. We are here to talk about all things Python education. Before we get into the business, we're going to talk about the code of conduct real fast. We want every attendee to feel welcome and having a good experience here at PyCon. Please familiarize yourself with PyCon's Code of Conduct and the attendee procedure for reporting Code of Conduct issues. There's a variety of links in there. They're all available on the us.pycon.org 2021 website. If you have any questions or you're not sure how to report an issue or anything like that, you're always welcome to message me privately here in Zoom, and I can help you get everything routed. So if there's something going on, we'll just take care of it. I've been on Code of Conduct committees at different organizations before, and my usual summary of Code of Conduct is be nice to each other, use welcoming language, and don't touch each other. The touching part, not currently relevant, but it may be in another year. We'll see. But be nice, use welcoming language. At least that still holds true. This tutorial, it's not a tutorial. It is a summit. This summit is being recorded. If you don't wish to have your video or voice part of the recording, please turn off both of those things. And recording has already begun, but I don't think we have any voice in the meantime there. And they're going to be trimming stuff too. So please remember that we are in a public venue here. So cool. Today's format. So everyone here, we had like 200 people register. And so I expect probably 70-ish will actually attend over the course of our 2 hours. Please, for the sake of everyone's bandwidth, because we have a very global audience, as we saw in chat earlier, please turn off your video if you are not presenting, just to save some bandwidth on everyone and save the recording. Speakers, of course, are invited to turn on their cameras and audio. Make sure, and I will be, as people are talking, I will be monitoring things and making sure everyone's muted. It's a default, everyone should be muted. So if you accidentally get unmuted, I'll go ahead and mute you on your behalf. So during the talk, when someone's actually presenting, please keep your questions inside the chat, but stay muted. Different speakers we're going to run things differently. They may ask you to take your mic and read out your question. I will be monitoring chat and all of those things as well. So also please no lengthy side conversations in chat. Zoom chats get really busy really quickly, and I'm trying to monitor it. And so is the speaker. And so if there's big, long threads happening, please just hold those. And one other thing about questions is if you can kind of keep your question to the side on your own computer for a little bit, or wait to ask it until the speaker has finished. Sometimes people ask questions and the speaker is just about to answer them. So sometimes it's good to wait a little minute to ask your question so you're not interrupting someone. But we will have question time after each one of the talks. The talks will run for 15 minutes. I will give speakers a notification in chat. So as you're speaking, please do keep an eye on the chat as much as you can. If need be, I will take the mic and remind you that your time is up, but I will not do that until your time is actually up, okay? After the talk, when we go into the Q&A, again, for the purposes of recording, I will go ahead and read out your question. The speaker so speakers, please wait until I finish reading the question to answer them. If you are just really into it and you want to read it out yourself, you can. You're very welcome to invite someone to add more information, but for the sake of speed as well, sometimes it's nice just to like read the question out really fast and not necessarily have someone reread the question, okay? So also just generally keep your questions as questions. Usually speakers are pretty happy to leave their contact information going on. And so if you have something like, oh, I think it'd be awesome if you know about this resource, you can throw it in chat and they'll grab that after their talk. Or you can send it to them via email or something, but please don't make the questions like, did you know about this? Or did you know about that? Because those are not really questions, and that's not really always super interesting to hear about. And so unless the speaker directly asked, where can I find the business for this? Please, you simmer down a little bit. I know you all know stuff. I'm a librarian and I can't help myself sometimes from sharing resources, but sometimes it's important too. So, all right. If you have any questions on format or how things are going, you can always message me in Zoom chat as well, and I'll be happy to answer. I have, so quick other remarks as I'm getting going, and then we're going to have Minal come in and talk about some of the Python education things as well. I wanted to split apart the education summit and the training summit this year because I wanted sort of we're going to talk about COVID, but I didn't want the education summit to just be COVID teaching's hard. Teaching in Zoom is hard because research still goes on, right? We're still researching CS Ed. We're still looking at all of this stuff. We research it, we practice it, we were presenting about it, things like here. For some of us, education and being an educator is an identity. For some of it's a profession, or for others, it may be just part of your job, like mentoring or internal training is just part of our job. And we're all here. And that's why I love the Education Summit, because we're all here joining because we have some interest in education along the way. So please explore the different ways we all teach and think about how teaching is actually a major part of all of our jobs. Our presence makes a difference when we are teaching. Just sometimes it's representation, knowing that, hey, someone else like me is doing this thing. Maybe I can do that too. And we talk about embodying the practice of our programming to students. Like, we want to normalize trial and error. We want to normalize the information seeking things. We want to do problem solving and show what it's really, really like. But especially in really hard times. Now, we've taught globally for millennia. We've taught in really hard times before. It's all happened before. It's all going to happen again. But in this space of teaching, we have the capacity to show our own resiliency and our own problem solving when we're dealing with pandemic stuff. And so I have really appreciated the ability to showcase to my students how we can all, a lot of my students already have grown up needing to be resilient, more resilient than they should be at their ages. But sometimes it's good to sort of see how to turn resiliency into more positive things. So anyhow, thank you for teaching. Thank you for coming here. Anyhow, let's talk about the talk. So we have some awesome stuff. We're going to be talking about making errors easier to understand. We're going to be talking about how we can better understand the learners in our data science classrooms, how to get creative practice ideas going on, how to do some active learning in Zoom, teaching across disciplines, and some really interesting creative math. And apologies if I misrepresented your talk in here. So I'm going to actually give it over to Minal to do a really quick update on some of the PSF education hub things going on. So she just has something fast, and then we'll get on to our first talk. All right, take it away, Minal.
Thank you, Elizabeth, and kudos to you for setting this up once more in a very quick and easy way for us. Again, this year, you did such an awesome job last year with the virtual summit, so thanks again. So Elizabeth and I have been partners in bringing together the Education Summit. We did that in person a couple of years ago. Now, during the pandemic, it is a virtual format. Hoping to go back to in-person summits and meeting all of the participants in person, learning their stories and sharing more stories about education, hopefully next year. So let's keep our fingers crossed. Today, I'm going to give a quick update on where we are with the PSF site for education. So this effort has been started by Meg Ray, who was our keynote speaker in the past summits and also our regular in education summits. So she was spearheading the Python website or Python education website through PSF. And just to let everyone know what this is a new landing page for Python in education coming on the Python website. This is funded by PSF. So there is a whole new page and material dedicated just to education. What you can do here is you can find resources, you can add resources, learn inclusive teaching strategies, connect with others in education, and contribute to this project as well. So this is a format, this is a way for us to share our educational material with others and make these open education resources available to more and more folks. So this site is launching as we speak through this PyCon. And after that, there is a mentored sprint on Sunday, May 16th, 12 to 4 p.m. ET. So please feel free to join those. There is technical and content contribution is welcome, and Meg will be there to show you how to add your content to this website. So thank you very much. That is all I had, and hope you have a great experience today. Thank you, Elizabeth.
Awesome, thank you, Meenal. And that project has been a long time coming. I remember over several PyCons discussing it with people in breakout rooms and all sorts of things. So I'm super excited. These things are getting launched. And if you could stop sharing here, we can go ahead and welcome our first speaker here, André, who is going to be talking about his package Friendly. So André, go ahead and take it away with screen sharing and audio.
Okay, thank you very much. Thank you to the organizers. I'm going to introduce Friendly. Who am I? I'm a Python hobbyist since 2004. I've spoken at a few PyCons, about the last one was in 2009, and I've met a few people here. And I mentioned at the time, and it's still true, that I'm a bit of an imposter because I've actually never taught Python to anybody except my children. But I make a whole bunch of tools that are used by other people to teach Python. Who are you? I'm expecting that you're Python educators or mentors, and this talk is prepared in this with this in mind. And so what is Friendly? It's a tool to help your students with Python tracebacks. We'll go into more details, but I just want to say that Friendly has now grown into supporting special cases for different environment in which it can be used. I'll start with an observation. If you're running a program with idle, mu, or thani, which are probably the best known editors for beginners, it's equivalent to running from a terminal with the -I option, which is an interactive mode, where you have a program. You have a program with a variable answer and a print statement. If I run my program, I see the print output, then I have a Python prompt waiting for me to interact with it. So it's sort of an agnostic environment. It's not specific to any editor. I'm going to use that for some demonstrations, for the first demonstrations. The first demonstration is a simple turtle program that you can see. The expected result is this, drawing a graphic. So I told my students, my virtual students, that they should write their program and do that. So I'm going to actually run this program, and I see an error there. Partially initialized module, circular import. What? I don't know what this means. It's just, I'm going to just drop that because those tracebacks are just too confusing. So let's start again with Friendly. The only difference is that I add an M after the -I and put Friendly before turtle.py. And I get a traceback here with nice colors. And did you give your program the same name as a Python module? That's the first thing that maybe that's the solution, is that's the case, is I wanted to use a turtle module from Python and I called my program turtle.py. Sometimes the hint that's added after the traceback is not specific enough or doesn't have enough information, so I can ask why. And I apologize for the noise from the keyboard. My good keyboard just died 2 days ago, and now I just have a noisy keyboard to use. So asking why, it gives me more explanation as to what may have caused this problem. You can likely tell from my voice that English is not my first language, so I'm not too sure about this explanation. I'm going to ask it again in French, and there it is in French. So Friendly supports any languages as long as it's English and French. I need translators for other languages. Let me switch back. So that's why sometimes traceback has many lines, and I don't understand where exactly were the problems. So I can ask where, and I get more explanation. By default, if the program is, if it's just a single statement, I will just get one place. If I get multiple frames, I only get the first and the last. Where the execution stop was when I was importing. What statement caused a problem is this one, and what part of the statement is underlined. Now, this was an attribute error. What is an attribute error? I have the message repeated here, and then it tells me what is that type of exception, just generic, not specific to my case. It occurs when, et cetera, et cetera. Still, this maybe doesn't help me enough. So what I can do is, the normal way to do things would be to go and copy this and open a browser and search. Well, www, entering that will do that for me. And here it goes and puts the message there, remove the apostrophes so that it's not, search engines usually will treat word in between apostrophes as special. You don't want that special because usually that's the irrelevant name, and it will do a search for you. So that's the quick demo. Typos. I'm not going to demonstrate typos. I'm just going to show some screen captures. We know that using a REPL, typos are not always friendly. So here I have another example where I made a syntax error, and it gives me a hint, and I need to find out more. So what I'm going to do is ask why, but I made a typo in doing that. So, but friendly is helpful. It says, did you mean why? Yes, I meant why. So let's correct that. Asking why, it tells me that I misspelled why before. What happened is that I made generated two tracebacks. The last one is the one on which I'm getting information, and that's not the one for which I wanted information. So what I can do is type back and check the history, and I'm back to where I wanted to be. And then I can ask why, and I will get the information that I wanted. How to install friendly? Python -m pip install friendly. If you do that, you will get a message that you need to do that at a terminal. I know there's a bit of a chicken and the egg problem here, but it's one error that friendly is able to identify. Okay. Now I'm going to do some demos with IDLEs, Mu, and depending on time, Jupyter Lab. I suspect I won't, and I know I'm rushing through because I want to show various things. I'm going to remove that, and go. I have IDLE here with the font size so small that you can't likely see it very well, and that's sort of on purpose. I'm going to run a program that generates a traceback. Run module with an IDLE, and we see a block of red text confusing to beginners, and at this point they will tend to panic and say, I don't know what to do, I don't know what this tells me, it's just too complicated. What I can do is I can use a second program in which I will import run from friendly.idle, the specific IDLE, and run my test program. So this is little program. I will run the module. And now you can see that there's black in between the red. So the lines of codes are highlighted differently. And I can ask where and find out this is the place that is very visible where the problem was. So just visually, I don't expect you to be able to see the details. Just visually, you can see that the traceback becomes potentially easier to understand. I'm going to use Mu now, but Mu, you should be able to see what I have. I have Mu for, I assume that most of you will have seen it. It's a great editor for beginners. So I have, I started the REPL, which is a Jupyter console, and typed in PyCon. I typed something, and that generated traceback. And I get name error repeated twice. This doesn't look like the standard traceback. The error exception name appears twice. Then there's this IPython input -1 dash. It's just, I don't know what that is. So I'll just ignore that for now. I have a file here with a program with 2 lines called error. So in this REPL, I can use a magic command run. Oops, error.py. It generates a traceback, and again, there's not much that I can do with that. List index out of range. I don't know exactly what this is wrong. So from friendly.new, import star, and let's run the program again. Now I have a regular looking traceback, list index out of range. A reminder that the first item of a list is at index 0. Why is that? Why? Tells me that I've tried to get the item with index 3, which is A3, for a list of length 3, but the largest valid index of A is 2. So this should be more helpful than the simple list index out of range. And I could also have where and various other commands. Now, if you remember, I had PyCon initially. I have now a regular traceback. I typed it again. It's again a name error, but the file name here is in 6. That is, this is the block of code in the REPL where I enter the problematic line. And if I had the traceback with multiple frames, they would refer, I could go back and figure out exactly what went wrong where. I'm going to skip over Jupyter demo. I have it running, ready to use if needed. Friendly used to be called friendly traceback. And we know that for Python, explicit is better than implicit. I changed it to friendly, and you may wonder why changing from a more explicit name to this new one. The reason is as I added more and more modules that were specific to various environments. I thought that friendly traceback was a bit long to type for beginners, and it's intended for an international audience. And I know that on some keyboards, typing an underscore is not necessarily the easiest, friendliest thing to do. So I thought by shortening the name might make it a bit easier. And besides, one of the speakers today posted this about his students. It was, I think, last August. Had this code with a print statement. Nothing was printed. And the thing that there's a problem with this code, it's valid syntax. There was no warning. And what it is that there's a colon here, which transformed this into a type annotation. So now the friendly console that I'm using will tell you if you use a type annotation without assigning it a value, it will give you a warning. Also, if you redefine a Python built-in, like list is equal to 1, 2, 3, which is a common mistake made by beginners, it will give you a warning that you redefine the Python built-in list. And if I go, I have time for that. Python : hello. Sorry, just repeating the error there. You can see a warning that I use a type in for a variable without assigning it a value, and it would tell me some options that perhaps I wanted to make something equal there. Why import star? As you saw, there was, I say from friendly.new import everything. And we always say to beginners, it's not a good idea to do that. The reason is that in addition to what, where, why, and www, there are quite a few other commands that are added to Python's built-in to help people with tracebacks. I've only demonstrated a few here in this presentation, but there's a lot more. So you wouldn't want to tell people, do from friendly.new import what, where, why, www, back, history, friendly TB, explain, debug, etc. So it's easier to do star. Many people made suggestions along the way, either directly or indirectly to me, and I've incorporated those ideas. I have many people to thank. Friendly traceback is used on the website hackinscience.org and futurequery.io. Where's the code? It's on the GitHub repository. There you will find a link to the documentation. If you find the documentation first, there's a link to the code repository. But perhaps there's a more Pythonic way to get at all this. First, install friendly, the usual way. Then start the console by doing Python-m friendly. You will get the friendly console. No exception raised so far, no traceback. Type in www, which does a DuckDuckGo search on an exception message. Since there's none, in this case, what it will do is it will go to the website where you find the documentation for friendly. As you can see, there's quite a few pages here. And oops. Friendly is currently at version 0.3.50. Try it and let me know how it can be improved for you and your students. And that's it. I don't know if there's any questions.
Yeah, thank you so much. I will go ahead and start the question moderation. So go ahead and throw questions in the chat. I'll read them out. So there's a request for if there's any time for a Jupyter demo, and we actually started a bit early. So
okay,
you have like 1 or 2 minutes, I think, if you want.
That's
I'd be curious too.
Yeah, okay, so let's show. This is, and again, you won't be able to read the code. I'll just restart the. This is when you have a normal traceback in Jupyter. This is Jupyter Lab running, actually. You get this traceback with a pink background with, you probably can't see here, there's this IPython-input-1, et cetera, and you have the code that's there. What I can do is I can do from friendly to Jupyter import star and rerun this code. And now I get sort of a nicer looking traceback, less jarring, and I could ask what, where, why. I can do all of this all at once by asking explain, and you see the traceback, you see the hint, you see what is a name error, the hint in my program, the location of the error, and I add cosine and pi and print. So it does mean that cos is a built-in a function, cosine print is a built-in function. If I had other variable names, I would have things there as well. So that's the one. There's also with Jupyter Lab, one could change. There's a theme, dark theme, and this is a bit jarring. So let me do this, and I can adapt it to theme. So everything that you saw me do in the terminal, I can do in a Jupyter session or an IPython console.
Awesome. There's a couple more questions here in the chat.
Yep.
Question is, they're curious how complete the package is. Will it work? Will it provide a friendly traceback on all tracebacks?
No, it won't so far. As I mentioned, it's version 0.3. My goal was to have all of the standard exceptions included. And at first, it was just to say what the exception means. The idea of explaining why, providing an example was not on my radar at all. I think it was Julien Pallard who first mentioned you can probably easily identify typos and provide an explanation. So I started adding that, and then other things were added. So even though you don't have, let me just go back and show you. Even though I don't cover everything, here's an example of syntax error. You can see a list here of potential syntax error that I can identify. And there's also name errors, attribute errors, index errors, import errors, module not found error, where I can provide detailed explanations. In total, I think that I've covered, I have over 200 different cases in my unit tests that are covered. So it covers most of the examples I could find. I found something from the University of Waterloo site, CS Circles, where they listed the most common mistakes entered on their site. And currently I covered 30 most common ones, which cover something like 90% of the cases of their students, and I'm slowly chipping away and adding more.
Cool. That's really fun. I can also see that as like maybe an interesting way to dump some of that out as like interesting tutorial documentation on what some of the tracebacks mean as well.
Yeah.
There's another question of if you could say a word or two about how Friendly works and how does it get access to the tracebacks?
It actually does frame inspection. It goes back, use the inspect module, does frame inspection, dig down, identify variables, extract the message, and then compares. I have a list of messages that I add. It goes through a loop, looking at first type of error. So within, I have a name error module, I have a import error module, and it goes through those and tries to identify, sometimes using a regular expression, if it recognizes the form of the error message, and from that digs down and tries to do some inspection. It's all hand-coded, case by case, that I explore on the REPL myself, and then I write something that's generic that can work for this type of error. It's not something that's automated. While I'm waiting for the next question, I'm just going to import an error. I don't know if people saw there was on May 8th, there was a new PEP proposed to identify where an error is found. And what it does is it underlines something like this. And so this is a non-type object, is not subscriptable, but there's some confusion by people saying, which one exactly? Is it the full thing or only partial that's none? And Friendly already can do that and tells you that it's this element that is equal to none. And then you're trying to do none bracket 3, and that creates a problem.
That's awesome.
And non-type means that the object is a value of none. Sorry about that.
That's okay. Yeah, I teach intro, and there's just a lot of errors that happen. I don't see any other questions in there. I do have a quick question. If do you have any sort of structured way to help translate some of the current explanations and things to different languages? And if someone had a class, say in a not English or not French, and wanted to help translate that, how could they help you?
I use a sender get text approach. So I have a so-called .pot file, which contains strings that are automatically extracted from the code. And so I have a French module, and by default, the English one is not translated. So you just have to import the file. I use Poedit as the editor for that, and it loads the so-called catalog and go to translation one by one at a time, and do that. So just standard tools.
Okay, cool. There's one last question I think we're going to do from Reuven. It seems like using Friendly requires the pip install and then from import. What's the easiest way to get it installed for total newbies who haven't yet run Python?
It depends. If you're using, for example, Mu as an editor, which I recommend as the very first for Friendly, clicking here on an icon at the bottom, there's something called third-party package, and you just have to type Friendly and press OK, and it will load Friendly and all the dependencies automatically. Otherwise, the only way is at the terminal, the standard way, and using pip install. With Thani, I think Thani has also something where you can type in the name of a third-party package and it will import it for you. Using idle, there's no other built-in ways to import things. So.
Okay, awesome. Thank you so much. So let's all do some nice clapping in the chat, please. And Daniel, do you want to go ahead and get on deck here?
Okay, awesome. Just one last thing for Jupyter Notebooks and Jupyter Labs. I believe if you have as a first command in a cell, ! pip install Friendly, that it will install it for you within the Jupyter Notebook or Jupyter Lab.
Yeah, that can generally work. Cool. All right, thank you so much. So we're going to go ahead and switch it over to Daniel.
All right, hello. So I posted my slides up in the chat just so people have them. So hello, everyone. My name is Daniel. I was a first-time PyCon attendee in 2019. I am currently a PhD candidate at Virginia Tech, where I passed my prelims in February, and hopefully I can graduate by December. So I studied data science education and pedagogy in the biomedical sciences. In 2019, I was an intern at RStudio, where I worked on a package called Grade This, which is an auto code grader that would check the actual syntax of the code and tell you what part of the syntax things got wrong, you were wrong. From the carpentries, I've been an instructor since 2014. I've been a trainer since 2020, and I'm also currently the community maintainer lead, meaning that I help maintain all of the carpentry lessons. And then from PyCon and SciPy, I teach pandas workshops, and I pretty much bounce back and forth between R and Python on a regular basis. As far as educational materials I've created, I wrote a book called Pandas for Everyone. There are 2 video lessons that accompany the book. And then I also have a Git video. All of this is going to version 2 sometime this year. I am also, for my dissertation, working on a project called Data Science for Biomedical Sciences that you can hit at ds4biomed.tech. And so just as a quick overview of what's going on in the data science education, essentially data science education is a commodity. There's content everywhere, and we're not missing content per se. What's really missing is the ability for domain experts to get more people using these tools. And the way to do that is improving data literacy. So like all of the librarians, I hope that, that is like the new cool thing to incorporate data science into our work. And if you look at courses being involved at the university, things around data products and data cleaning aren't actual explicit classes. They may be incorporated into existing classes, but they're not really called out explicitly. And so we have this ability, since data science is democratizing, the ability to spread it across more specific domains and branch out. And so why does domain specificity matter? Well, it's because you learn more or you learn better when things are more relevant to the things that you care about. And so that also factors into things like internal motivation. You're more receptive to feedbacks, and you can create positive feedback loops for learning. And then you can work towards, or the learner can work towards, being self-directed. And so one thing that we want to think about is identifying who our learners are. And so there is this notion of a concept map. You can also use a process called task deconstruction. And essentially each node in the concept map becomes a bit of knowledge, and then they're connected by edges, and that's how the knowledge bits are intertwined and related to one another. And depending on the density and number of nodes and how they're connected, you may be able to say that relates to some spectrum on the Dreyfus model skill acquisition between novice, practitioner, and expert. And the actual Dreyfus model has 5 components, from novice, competent, proficient, expert, and master. So it's all on a spectrum. And so how do we go about identifying those bits for the concept map of what our learners know? Part of my research, I have a IRB approved to run this set of surveys. It's currently going through like a proper survey validation step. But it's really a combination of the carpentries, how learning works, and teaching tech together. Like they have a whole bunch of survey questions, and I mashed it all into one giant survey. And so there's really 8 components. 16 of those questions around programming experience, data cleaning, project and data management, and statistics. I can take all of those components and cluster the results. I believe the N for my research is around 44 or so, 42 to 46. And so we can cluster those results and then use those results to create our learner persona. So at least in my particular case, we have Claire the clinician, Samir the student, Patricia the programmer, Alex the academic. And a persona is really a fictional character that encompasses one type of learner that you are trying to teach. And it can work in teaching. It can also work in general marketing or many different fields. So this is one example where Claire keeps up with medical research, but has no to little experience doing the medical research. They use Excel for non-data related tasks, manually inputting data into spreadsheets for chart reviews, and want to be able to collect data and eventually be able to do their own study one day, right? And that's information I got from demographics and free response. And then you fill out the rest of the persona with background information, perception of needs, and then special considerations, which is more like external factors that can make learning difficult for that particular student. And it's all for you as the instructor to keep in mind, like there are many components going on for each individual learner. And you create this persona across all the different components, and then you try to build a lesson plan around it. So how do we go about planning the lesson? Because everything was focused around Excel and spreadsheets, and these are working professionals, I created these 8 learning objectives, mainly focused around how do we transition from spreadsheets, knowing how to manipulate a spreadsheet, knowing when to not use a spreadsheet, and then pivoting into what is the concept of a clean data set or a tidy data set. And then from there, you can branch out into doing plotting or analysis and all the other cool stuff that we usually see in data science courses. And so those verbs or those learning objectives comes from Bloom's taxonomy. I wonder if the Teaching Python podcast folks are here, where Kelly and Sean talked many times in their podcasts, where when you're trying to teach this material, don't think about the taxonomy as like you have to teach from each level one layer at a time. You can teach the bits of information in the remember layer, then jump up and apply that information, and then go back and teach the next bit of information and then apply it again. So you're teaching new materials, but also reinforcing older bits at the same time. And so that's why the focus was around tidy data, because it was such a core concept of getting a clean data set or identifying what is a clean data set is pretty critical in like both sides of processing your data and getting your data, like where you're getting your data from and processing it later on, right? So data is messy in different ways, but all clean data sets are alike, right? And so one of the examples we go through is this tuberculosis data set from the WHO. And you can see like for any one of these counts for a particular year and country, we have things like male 15 to 24. So this, for example, 228 represents a gender and an age group. And that's problematic if you want to do some kind of analysis or summary statistic. It's harder to say like, what is the number of counts for all 15 to 24, because the female counts is in a separate column. And so you can go through this process of doing this melt command, which is shown on the left, and then taking that column and splitting it into gender and age, right? And this is really useful because it allows you to delay certain computer science concepts. For example, loops. You don't necessarily have to teach a for loop, and it allows you to bring functions a little bit earlier, and then you realize that most of data manipulation is done on a column basis. So then that becomes an apply or a mapping call versus an actual for loop. And that's sort of the difference about how you would think about manipulating data versus like general computer science data structures. And so this different view of data is something that I try to hone in for my students, because there is a form of data that is really easy and good for data entry if you're manually entering data. And then there's the form that's really good for doing the actual analysis. And if you're trying to teach someone how to get into data science and they're a working professional and they want to get their study really quickly or starting to learn the field, being able to input data and then seeing how they can use that data for their analysis later on is really important. And so one example, and this is like the summative assessment question I have at the post-workshop assessment survey, is they have CMV activation, which is a virus that's usually not a problem, but they have this they potentially have this problem after a stem cell transplant, right? And then I asked them, given this data set, do a couple of tasks. So the first task would be load an Excel sheet. And then each one of these components, if you look back at the concept map, has a lot of things going on, right? So import pandas SPD, you have to know how to load a library, load an alias, even loading up the CSV file, you have to know how to use a library function. You have to know about relative paths. You have to know about variable assignment and then functional arguments. And then the next task I asked them, go filter your data. So you have to know how to subset rows or columns. You have to know about Boolean conditions. saving data as an Excel file is sort of realizing that you can save out and write out intermediate bits to send off to other people and part of a larger data pipeline. Then you have this notion of tidy data, which is you have to know about lists because now we're talking about multiple columns. You have to recognize which of the pivoting directions you're trying to go. Are you going from wide to long or long to wide? And then you have to know about like keyword arguments, not just positional arguments. And then we can actually go through like the things that the data products that people care about, which is like make a plot. And then once you get to this point, because of everything that you took and had to cover to get to tidy data, now it's a little bit simpler. You're more just concerned with what is the plot I'm trying to make, or what is the column I'm trying to use. When you're trying to fit a model, then you have to worry about which are the columns that I'm going to use for predictor and response. With model fitting, there's other things you have to know about, which is like dummy variables or one-hot encoding. That's something that needs to be covered. You have to know what is the correct model at hand. So in our current example, it's a binary variable whether or not they had a CMV infection. And so logistic regression would be a good model for that. And then given logistic regression, you have to know how to interpret the results, right? So in logistic regression, you typically exponentiate the estimator so you can report things as an odds ratio. That's sort of like the 10-second intro to statistics for everyone. But that's a lot of information that needs to get covered. And so in essence, data science is really different from computer science. And for example, one of the Canterbury question banks, and this is sort of like what you get from like the Project Euler type questions, is here's a binary search problem. I never really work with binary trees in my data science work. I imagine a lot of people who manipulate data don't have to worry about this stuff. They might use functions that use this type of algorithm, but this isn't the type of thinking or processing that most data science tasks need to perform. Having said that, if you're trying to write a function or a library, you might have to do something like this. But as far as general data manipulation, this type of question sort of exemplifies like one of the key differences that's going on. And so we can still, like everyone here, we're all very concerned with computer science education. And I think the biggest difference is the data frame object is actually not a standard computer science data structure. And so that means that we can still teach programming related things, but certain things can be delayed, and then we can bring more of the other concepts forward because we don't have to worry about them just yet. Like I talked about for loops, you still eventually need to know how a for loop works, but you can sort of push that off much later on and talk about functions and applying them down a column. And so if we compare data science education resources, for example, R4 Data Science by the RStudio folks, tidy data isn't considered, they don't talk about it until chapter 12. Iteration isn't talked about until chapter 21. The way they did it was they emphasize data visualization very quickly as essentially the first thing they do, and then talk about workflow stuff. So that is the type of audience that they're working with. Maya Gans, Toby Hodges, and Greg Wilson wrote a book called Data Science for JavaScript. And you can see at the very beginning is a lot of like HTML, CSS, JavaScript related things, and it's very programming focused. And then they bring in the data related work before putting it all together. And I'm not saying any of these ways is right or wrong. It's, you know, they're for a different audience, and it's really good to be very explicit with who your audience is. So Python for Data Analysis by Wes McKinley talks about the pivoting, merging stuff at chapter 7, but he also puts a lot of emphasis into like the IPython environment and NumPy basics, right? And this is partially because this is really good reference manual. And so you want a deeper understanding with all of those things. There's a book by Matt Harrison called Learning the Pandas Library. And you can see that he goes through a lot of detail with these core pandas data structures before going into the data manipulating things. Even my own work has changed over the years. So for Pandas for Everyone, that wasn't, tidy data wasn't until chapter 6. Because I ran through this persona stuff and I wanted to tie everything to spreadsheets as far as possible, you can see like the major first topic really is, even though it's still chapter 6, if you look at the beginning, it's a lot of setup, talking about working directories and like setting things up. And it says R&R Studio. It's really all language agnostic. I'm going to write a Python portion for it as well. So don't worry too much about that. And then all of the conference workshops I do, I literally say, here's how you load up a data set, subset, and then we talk about tidy data right away. And so that's sort of how I've evolved dealing with the people that I end up teaching regularly. So how can you use all of this information? I told you, identify who your learners are, figure out what they need to know, and then try to plan a very guided learning track for them. And then you're free to use the surveys that I've put together to help you figure out who your learners are and what they need, what they know, and how you can teach them. So there's a bunch of additional resources. There are things there, and then here's the part where everyone takes a snapshot for like slides. So questions.
Awesome, thank you so much. Go ahead and queue up questions in the chat, please. While we're waiting for some of the questions, this is really awesome. I would love to chat with you because my own research work is in sort of the information pathways of learning data science, particularly for adult, like professional education in the sciences as well. So I'm curious if you sort of in doing some of this big scaffolding stuff and making these personas, if you sort of encountered or seen anyone like really explicitly talking about the information pathways. Like, how do you go from I have Excel, need to make a histogram, how do I do the thing? How do you find that kind of stuff?
So I found out that was the pathway from the surveys that I gave out earlier this year, part of like my actual study. So I put that together, and then the feedback from the workshop was like, this is exactly what I needed, because you end up with all of these roadblocks of like, they can't even load up their data set because they don't understand paths, or like everything is in one folder. So they have 500 files in a folder and things are all crazy and they don't understand why. So it's sort of like me being very conscious of all of the connections that I have in like my concept map, and then breaking it apart into excruciating, complicated, like small detail.
It's the hardest but most necessary work, is breaking all that apart.
Yeah, and it's like that trade-off, because like I spend like the 30 minutes going through like how we can load up data and paths, and that's 30 minutes that could be taught something else. But then it's so critical for like that initial step of like getting your data set loaded, because I'm actually want you to get out of Excel to do data processing. You can use it for other things, but don't do it for like actual processing.
Yeah. And stuff like this is really good as well, because I think as educators, we have not done a great job of really challenging the traditional learning outcomes of our classes. I think the carpentries does a great job of this, because we know we have a limited amount of time, and we need to think like, when I leave you here with a thing, the things I need you to be, what are the sort of the life survival skills going, and sort of actually breaking apart these life survival skills really helps us prioritize those things. All right, we have a question from Kevin. Can you speak some about the good processes for teaching students about tidy data?
Yeah, so there's a few things. This illustration comes from Allison Horst, who's mainly in the art community, and she does a whole bunch of these types of illustrations. If you go down here, there's like a link to her tidy data illustrations and paper and talk about teaching that. This set of tables comes from the tidy data paper by Hadley Wickham, again from the R world. But it's also really good about explaining like what is actually going on, and like why you would want to care about it. And so that's what I've been using. And then the other resource is you can read the beginning bits of tidy data from the R for Data Science book, which is a lot of, they talk about like just the conceptual bits of tidying data. So that's a bunch of R resources in the Python world, but that's sort of just what I end up going to. And from a conceptual point of view, it's actually really good.
Awesome. That's going to put us at time. So we get a nice set of claps in the chat. and go ahead and get Reuven. How are you doing? On deck.
Hello, I'm here.
Hello, got ya. Welcome. Go ahead.
All right, folks. So let me share my screens here. So if I share the screen, share. Yeah, I should be able to share the slides, I think. All right, you see them correctly?
Yep,
Yes,
I
hopefully.
see slides. That's super
fantastic.
Okay.
Okay.
That graphic design.
Well, this is as great as the graphic design's going to get, folks. It goes downhill from here. All right. So my talk is practice makes perfect, but what kind of practice? And whoops, for those of you who don't know me, so I've been using Python for close to 30 years. I know it's like shocking to say that. And I've had my own business for about 25 years, and I've been teaching Python for about 20 years at this point. And nowadays I'm a full-time Python trainer. So just about every day I'm in a different company, sort of teaching everything from Python for non-programmers up to advanced workshops. I do on-site courses, and I've got some online courses as well. And my background is in this combination of computer science and learning sciences as well. So we love to say practice makes perfect. Are we sure? Are we really sure about this? Like, it sounds really good, right? But like, does it get to be perfect? Well, how about practice makes you really good? And so while this expression has been around for a long time, where does it fit into reality? Well, let's start off with like a little bit of background thinking about it. So we intuitively know that practice helps us to learn, right? So with language, both our own native languages, you got to practice it in order to get better at it. Something like sports, which you could argue even as much as I practiced wasn't so good at it, but I got better than I would have been otherwise. And yes, with coding, right? So just about any sort of skill, you have to practice at it. And we know, and we believe because we're educators here, that if we as instructors help people, they will get better even faster than they would have on their own. Well, some researchers about 25 years ago actually sort of put this to the test. They said, well, if people do deliberate practice, right? If people are sort of really purposely, systematically over time, putting in lots and lots of practice time, is that going to make them better? And is that going to make them the best? And they basically came to the conclusion of, yeah, actually, more practice means more expertise. And they compared, if I remember correctly, a bunch of violinists. And these were all good violinists, were very good violinists. And some of them were like the top, the best ever. Some of them were sort of like close to that. Some of them were not as great. All of them better than like most violinists out there. And they basically said, well, you see, the reason why some of these people, let me bring the mic closer, the reason why some of these people are truly amazingly fantastic at it is because they practice even more. And so they saw it as almost like this like one-to-one correspondence between the more practice time you put in, the more of an expert you will be. And Malcolm Gladwell quoted this, and it became very well known, still is well known as like the 10,000 hour rule, that if you put 10,000 hours into something, then you are going to be an expert, and you'll be really fantastic at whatever you do. Well, it turns out that some researchers a few years ago looked into this a little more, and they were like, well, it is true that putting in a lot of time will make you very, very good. But to say that there's this sort of linear correlation between the more practice, the better you'll be, right? That's just not true. There are actually some factors out there. There's genetics, there's environment, there's who knows what. So, I mean, they know what, like they checked into this a bit. And so there is no question at all that practice is good, but you shouldn't assume, oh, well, if I practice twice as much, I will be twice as good. It's just like life is not as good as that. But good practice and well-structured practice and varied practice does have some clear benefits above and beyond just basic old learning, right? We know that if we're learning a foreign language, you got to practice speaking and reading and writing and the verbs and the nouns and the grammar and all that other stuff, right? And the more you do that, the better you will be. But it turns out that practice is not just a quantity thing. One of the best known problems in education is the problem of transfer, that if I learn something in a particular context, then that knowledge might only be or best be accessible in that context. And there's all sorts of research showing that transfer is a real problem, that basically I might be great at remembering certain information in school if I learned it in school, but then I have to use it in the real world and I'll come to a complete blank on it. or I'll learn it in one class or in one form with certain people. And so good, varied practice reduces transfer problems. And that, of course, is something that we are encountering when we are teaching. That basically, if I'm teaching someone Python coding and they are fantastic at it in my classroom doing my exercises, but then they go out to actually do work and they don't know how to apply what they've learned, well, that's not really doing them much of a service. And so it's not just enough to practice a lot. You have to have a lot of varied practice problems from coming from different perspectives, forcing them to think in different ways and use tools and use ideas like again and again. But as I say, like in a varied way, thinking in different ways, thinking in different, and even talking to other people about it. Now, I happen to love exercises. I see the benefit that they give to my students. They really can then, done well, done right, put their knowledge to use right away in the classroom, which is a huge boost to their ego and motivator, right? It's like if they're in a classroom where the professor or the teacher or the instructor is just talking, they're definitely not going to be motivated. But if they're given an exercise after 2 hours of lecture and it's so incredibly difficult that they just give up, that's not very motivating or good either. So finding the right level, making sure that it will test them and push them and make them sort of sweat a little bit, what I call controlled frustration. Yeah, they're going to be frustrated, but it's like for a short period of time and they can get some help while doing it and just get them over the edge so they can do it. And they say, wow, I can really do this. And I especially love seeing this. I mean, a lot of people I know don't like teaching beginners, although I think like this is a crowd that actually does. But one of the reasons I love teaching beginners is because they feel like, wow, I can actually do this. This amazing thing called coding that I thought was completely beyond me. I can actually pull it off. And little by little by little, they can do more and more and more interesting things. But the exercises are also useful for me as an instructor because I can see where people have holes in their understanding. You did this part right, you did this part right. Oh, but you didn't quite get such and such. Right. And again, with beginners, they often don't realize, for example, that strings are inside of quotes and variables don't have quotes around them. Something that's super incredibly obvious to those of us who've been coding for a while, but it's not obvious if you're like, a beginner, a normal human. Exercises can also give you a chance to solve real world types of problems. Now, real world-ish problems, right? Because if it's a really real world problem, it's going to probably take too long for us to do in class. And I love to have, like, as I said, lots of exercises. I aim to have about 30% of my training time be exercises. And a lot of that is just sort of working and thinking. And I go around and I talk to them, or I talk to them, online as it is nowadays. And I found sort of something surprising over the years of doing training, that every year I sort of remove content from each of my courses and I give them more exercises and people love it more. And people feel like they've learned more and gained more from the course. So this notion of, I'm just going to stuff lots of content in and ask them something every so often, don't do that. They will actually be more satisfied and they'll have learned more. So because I sort of love exercises so much, because I've been thinking about them a lot, I thought it might become useful to sort of show you a few different types that exist. And these are sort of types of exercises that I tend to pull out as necessary. And some of them fall into multiple categories. Now, these are the only kinds. I'm sure if we were to do a full taxonomy of exercises, we could come up with all sorts of stuff. But what I find also is that after creating lots of exercises and thinking about the types of them, I'm actually pretty good creating new ones. And sometimes I'll even sort of push myself and do it on the fly. Like, oh, I'm teaching a class. What can I give them? Oh, hey, that worked pretty well. And some of my best exercises actually have come out of this forced, creative, reckless daredevil thing that I sometimes do. Let me try something completely new. If it goes well, I'll try it, again. And if it goes sort of well, then maybe I'll try it once or twice more with some tweaks. So what are some of these different types of exercises that I might want to try? So one of them I call monkey see, monkey do, right? Meaning, of course, have your students copy what you've done. And this might seem ridiculous. What kind of exercise is that? Well, it's really good for just sort of getting them started. Is the environment working? Right. Again, when I'm teaching total beginners, they don't know what Python should look like, how it works, what they're going to be doing. And so if I ask them, hey, can you type this and see what you get? First of all, they're excited that it actually works. And second of all, if it does not work, then I can help them. Way better to help them out at the beginning point than while they're like going through all sorts of coding and then it's a lot more complicated. Also, they can start to internalize the mechanics of this new knowledge. Right. So a lot of these things you internalize over time as you do it again and again and again. Your fingers sort of get to know these idioms. And so by teaching them from the beginning what they have to type to get input, what they have to type to put out output, what they have to do, like simple things, they're going to do it and they're going to internalize it. They're going to know how to do it again. And you can then use that exercise as a building block to do something more complicated later on, either right away or a day or two later in the course. And so, simple examples are like, hello world, print that on the screen, or as I like to do, get their name and then print something out as a result. But maybe we can do something more complicated, like, oh, we're just learning dictionaries, so I'm going to create a dict representing a person. We'll have the keys be like first name, last name, age, shoe size, something like that. And even, if you're doing a data science course, well, classifying irises using the K-neighbors classifier, I mean, it's not the most complex data science problem in the world, but they have to get through how they're going to fit, how they're going to predict, what it's going to look like, so they can sort of understand just sort of like what looks normal, what looks reasonable. So another kind of exercise I like to talk about, this might like date me as someone who watched The Karate Kid so many years ago. I know there's like a TV show about it now, Cobra Kai, but I haven't really seen that. In any event, so the boy whose name, of course, I forget now, he's basically trying to learn karate. And this guy is teaching him, no, the way you do karate is you're going to wax my car. You're going to wax it this way. You're going to wax it that way. And he gets really angry. He's like, why are you teaching me to wax your car? And it turns out that he wasn't teaching him to wax his car, although maybe that was a nice benefit. He was teaching him the basic moves he needed, the sort of toolbox he needed to do karate. And so you want to do that with your idioms in Python. Teach them, when to use certain data structures. What methods do you need to know? What kind of loops are you going to run on lists and on dictionaries? And they get to learn these idioms so that when it comes time to put them together, it's the putting them together that's complex and interesting, not the idioms themselves. Those have become second nature. Another kind of exercise I like to do is re-implementing things you know. They already know what a sum function does. It sums up a list or another iterable of numbers. So now implement it yourself. The WC Unix word count program utility. Well, even if you don't know what it is, you can sort of understand what it is. Implement that. Implement range as a generator function. First of all, people know what the specification is. They know what the goal is. And it turns out the implementation can sometimes be a little tricky. But once people get over that hump, they're like, wow, I can actually implement one of these things that Python does. And if you have really advanced students, you can sometimes add like a bonus. Say, oh, if this is easy for you, if you finish right away, try to add this or this different twists, right? So WC, you can say, well, don't only count words and lines and characters, also count unique words in the file, right? Or maybe make it case sensitive, insensitive, that sort of thing. Another thing we could do, and I mentioned this a little bit earlier, is like a stage series. So we're going to start off with one exercise and then use it a little later in something more advanced, then use it a little later in something even more advanced. And it doesn't have to be right away. You can refer back to it a day or two later. And one advantage here is that people feel like, wow, this is how software works. I'm building something bigger and bigger and bigger and more and more complicated. But it also helps you as the instructor, because if people stop after each step, then you can see where they're having trouble and you can try to identify it. And you could try to help them out before you go on to step 2. You could even say, okay, those of you who didn't finish, here's my solution to step 1. Now you can all try step 2. So one of my favorite examples is to do a Pig Latin translator for words, and then we'll do sentences, and then we'll do files. Or you can have a book, and then a shelf, and then the books on the shelf. Or have an appointment table, and a people table, and then a join table if you're doing SQL, right? Or you can do a classification with one estimator, and then let's compare different estimators. So all these things are possible because we're building and building, and they know we have this common vocabulary, and we're building up and up and up like we do in software, right? Higher and higher levels of abstraction. Now, one thing that I would love to do, but I don't really do very much, is solve a real problem. I love the idea of solving real problems in class. But you know what? Sometimes these usually take way too much time. And I've thought on occasion of having these like open-ended problem courses. I haven't yet done it. I know that some people do, and I love the idea of doing it. I just find myself too constrained with time. And also I have corporate clients. They're usually not that interested in it, even though like I think it'd be great. Sometimes I can sort of finagle a little bit. So like in my regular expressions classes, I'll say, let's spend the last half of the second day, like the last half of the last day, bring in documents or bring in files that you have to work with, and let's see how we can parse them together. And they are amazed that, hey, what do you know? They've actually learned the techniques they need in order to get this to work. Another thing we can do is like connect to this, right? So I'm going to provide already a class or a function, and their job is to use it or connect to it. So I'm going to provide an API. You implement a module, I'm going to actually, I'm sorry, I'm going to write something that uses an API. You have to implement the module that provides that API, or the vice versa. I'm going to provide a web service and you have to connect to it, or I'm going to, anyway, one or the other, the client or the server. You can also say, well, here you have to design an adapter for an existing class, something from design patterns. And so they don't have to write everything. They just have to write the sort of important thing that kind of simulates the real world. Removing bugs. I don't do this that often, but you can provide them with software that does not work, have them find the problems, and then make sure it works. This is perfect for courses in like testing, right? So figure out what the problem is by writing good tests and then making the software work. Or like if you're doing something with MyPy and type annotations, provide code that's not annotated and then have them add the annotations so that it goes away. The problems go away if they do minus strict. Now, I'll tell you, sometimes exercises don't work out. I have on some occasions given exercises that were literally impossible to solve. I know, embarrassing, but like I discovered this after the fact, or when they were trying to solve it and then I tried to solve it. They were poorly specified. They were too hard. My favorite example was the Scrabble Best Word Finder. Given 7 letters, find the highest scoring word. Yeah, that needed to be broken up. But when I broke it up into little pieces, then people were able to do it. When this happens, laugh. Laugh at yourself, laugh at the situation. Don't get angry, and certainly don't take it out on the students, because like at the end of the day, it's our exercises. Just to add one more thing here, which is one of my favorite phrases to use when teaching is, unfortunately, this works. And this comes up very often when I am reviewing exercises with my students, that it's not enough to just show them the solution. You want to show them the process used in coming to that solution. So I'll solve it for them little by little, typing it in live coding, because that's what I typically do. And then I'll purposely make mistakes, and I'll purposely make common mistakes. And then I'll say, unfortunately, this works. Then we'll roll it back and see what, or this does not work, right, if it doesn't. And so we can find unidiomatic code, unPythonic code, how it can be improved. And along these lines, I often like to ask students who have failed, I mean, not failed, but like students who have gotten it wrong, okay, give me your code, let's go through it, let's see how we can get it to work. And if they're embarrassed, they can, especially online with WebEx or Zoom, they can send it to me anonymously in the chat, and then I can go through it so they don't get embarrassed. I often find that when someone gives me non-working code, many people have made those mistakes. And so by going through it and talking about it, it's actually great for people. So practice might not guarantee that your students will be world-class coders, but a lack of practice guarantees they'll do poorly. So lots of practice is good. And you want lots of exercises, and you want to think about the exercises you're creating and have them fit together so they have different types of exercises on different sorts of topics, used in different ways, building in different ways. You will learn also from the questions that your students ask you about these exercises, and when they don't quite understand what you're talking about. And don't be afraid to try new exercises, and when the ones that don't work, okay, you throw them out. And just one last thing, I like to say, a little whimsy goes a long way. Be silly. So many instructors think that they have to be serious and never tell jokes and never have fun. The learning, I think, is enhanced when you have fun in a big, big way. And if you're like me and you tell lots of dumb jokes, that's okay. At least you will laugh at your own jokes, as my students well know, because certainly they don't. All right, folks. Thanks for listening. I would be delighted to answer any questions or comments that you have now. I'll add, by the way, that I have 2 free newsletters that I put out. One is free weekly Python articles at Better Developers Weekly. And I also have something called Trainer Weekly, which is about the training business, the pedagogy, business, and logistics of the training business.
Awesome.
All right,
Thank you.
questions.
Yeah. We have about 1-2 minutes for questions.
It's okay, I talk fast.
Yeah, I often describe like my job as an educator is to curate the fights that they have and to like make sure that they're fighting the right one. I remember attending a workshop where it was like machine learning, but all of the example problems were just matplotlib trivia. And I survived about 2 hours of a 2-day workshop and then just did other stuff. It was pretty horrible.
Oh my God.
All right. Any questions? Go ahead and throw them in chat. Okay, it is 1:20, so we're gonna go ahead and do some nice clapping here in the chat. Thank you so much, Reuven.
All
We'll
right.
see you.
Thanks,
Well,
folks.
I'll see you asynchronously tomorrow
Yes.
in the Trainer Summit. So, alrighty, stay
All right.
safe there.
Talk to you soon. Thanks very much.
Bye. All right, next up we have Marley talking about from room to Zoom. So Marley, are you here? Yeah, go ahead and take over, and I'll leave it to you.
All right, thank you. Hello, I'm Marley Kalt. I am a data management librarian at Johns Hopkins University. So I have my email and our website up on this slide. And today I'm going to talk about how we took our in-person workshops online. So I'll start with a bit of context about our Python workshops, and then I'll get into the strategies and technologies that we used to help make our workshop successful. And finally, I'll share some feedback from our attendees and from the instructors, which would be myself and my colleagues. So for a bit of background on our workshops, I'm going to focus today on our Python workshop called Introduction to Python for Absolute Beginners. So this is the only Python class that we teach at the moment, and it's designed for people who have no programming experience. So we first offered this intro class in fall of 2019, and it was an in-person class at that time. We typically run the class twice a semester. It is about a half-day class, started as 3 hours, but we've tried to cut it down to 2.5 hours, especially being online. And they can be pretty large classes. So for our webinars, we usually have about 40 to 50 attendees. And in terms of format, we do have quite a bit of lecture because we do want to set up our absolute beginners for success. But we also have a lot of live coding and hands-on practice. And since we went virtual last March, we have offered this Python workshop 4 times in a virtual format, but we do quite a bit of teaching and practice with virtual workshops. So by my count, we've had 78 virtual workshops in the past 14 months. And so this includes the Python workshops. It includes other programming workshops in R, and then workshops in other areas we support, like data management and GIS. And so a bit about our attendees, just for some greater context about who we're reaching. So our workshops are open to anyone at the university. For the Python workshops, we primarily get staff. We tend to get a lot of research staff in attendance. And our second largest group is graduate students. And we see our attendees coming from a really wide range of disciplines, but primarily from our School of Medicine, our School of Arts and Sciences, and School of Public Health. So when we started this Python class in 2019, it was in person, in a classroom, and we had a very highly controlled environment. So we were able to provide laptops with any required software ready to go. The instructor would have 2 monitors up at the front of the classroom, so we could display our PowerPoint slides and any code we're writing side by side throughout the entire workshop. And we would have TAs walking around the room to offer assistance. They could sit down with our students and help with anything they needed. And when we went virtual, all of that went away. We really had no idea where our students are and what might be available to them. And even continuing with virtual workshops, we have a new group of attendees at every workshop. And so we don't know where they are, what technology they have, what's going on. So the first thing that we asked ourselves in order to help make sure our workshops would still be successful online was, how can we minimize some of these barriers that our attendees might be facing? What can we do to make it easier for our students to jump into the class and stay engaged and follow along with the class throughout the entire 2.5 to 3 hours? So we really had to ask ourselves, where are our students? And I mentioned barriers on the previous slide. So there are many potential barriers that our attendees might face when they're working from home. But in our thinking, we tried to focus on some of those barriers that we might be able to have some control over. So we're really focusing on what technology that our attendees might have available, what skills or knowledge they have, specifically relating to programming skills and knowledge of different video conferencing or chat platforms, and how much time might attendees have to prepare for this workshop. And so when thinking through all of these questions, we always try to think about the minimum of these resources that our students might have. So since we're working with a beginner audience, we pretty much assume that our attendees will have a computer or a laptop, and they'll have internet access because they are attending this workshop online. But that's about the end of our assumptions. So again, in answering these questions to help make our workshops transition successfully to the virtual environment, we made several changes to our workflow and really tried to carefully choose our technology to help ease the transition for our attendees. So in terms of our workflow, one pretty simple change that we made was to provide our class materials in advance. So we used to send out our slides and any scripts after our workshops, but with virtual classes, we started sending out at least the slides in advance because we know that we'll be sharing our screen and switching between slides and code. And we thought that having slides for our students to refer to would be helpful for them. So we send out everything in advance. Students can pull up the slides when they need them, even if the instructor has switched off of the slides to show some live code. We also try to set expectations before the class a bit better than we used to. So for the in-person classes, we would pretty much say, show up and we'll give you everything you need if you don't have a computer with you. But because we can't provide any laptops or troubleshoot in, we'll send out a pre-class email with any required downloads. And we say that students will need to switch between Zoom and maybe PowerPoint slides and the coding environment. So we can try to set expectations and prepare students a bit that they're not, overwhelmed by the number of windows that they might need to have open during a workshop. And our last major change has been experimenting with different workshop times, especially having more evening workshops. So we know people are tuning into our workshops from all over the world. So we've tried to offer more evening workshops and varied times to help accommodate different schedules. And then on the technology side, the three main technologies that I'll talk about in depth for our workshops are Zoom, Poll Everywhere, and Replit.com. So Zoom, pretty simple one, something that we're all familiar with as we're using it right now. And it's also widely used at Johns Hopkins, so we knew that I would be familiar to our attendees. It was a pretty easy decision to hold our workshops on Zoom. But in terms of how we use it, we do keep everyone in the main session rather than using breakout rooms because we don't want people to miss content as we're trying to answer questions and do any troubleshooting. So instead, we use the chat for any questions that come up throughout the workshop. And we found that this does work well and helps keep everyone engaged in the main session. But then we also make use of our break time and some time after class. So if there's in-depth troubleshooting that needs to happen or someone wants to screen share or have more of a conversation, we can have more of that one-on-one assistance during a break or after the class as well. And we do have assistants, at least one TA, if not two, during the workshop to help monitor the chat. I do want to point out one of the I guess, negative aspects of using Zoom is that it's really not designed for sharing code. So we found that at the beginner level, we're writing very short statements. So if we're trying to troubleshoot or type anything in the chat, the Zoom chat does work fine for the introductory workshop. It also works because we don't have to teach another chat technology on top of trying to learn a brand new programming language. So we do stick with Zoom here, but I just want to point out that for more complicated code that has more lines of code or more formatting, the Zoom chat really doesn't work well for that. So that's just something to be aware of. And even though we do try to minimize the number of platforms that we use for our teaching, we do have a different platform for any polls or quizzes, and that is Poll Everywhere. So we can set up our polls on the Poll Everywhere website, and they have a PowerPoint plugin to embed polls right into our slides that we present. And we find that using Poll Everywhere can really encourage participation. When we've asked questions and asked our attendees to answer in the chat, we usually get a few responses, maybe 5 to 10 in a class of 50. But when we use a poll, we find that the majority of attendees are responding. So we have a much higher participation rate. They are anonymous, so that might help too with the response rate. I also like that Poll Everywhere has different question types beyond multiple choice, so it's much more flexible than what we can get built into Zoom. And there are several different options to participate, so you can do so through a web browser or texting in an answer. And the last technology that I want to highlight is Replit.com. And this is how we do our live interactive coding during the class. And Replit.com is a full-featured and browser-based IDE. So it works with Python and many other programming languages. And Replit has all of the features that we need for our intro class, like an interactive console, basic syntax highlighting, but it also has features that are great for collaboration and more advanced coding, like debugging features, and it integrates with GitHub. So this is, I think it's a great tool for our attendees to know and something that maybe they can make use of after the workshop. But it's also really great for teaching at the intro level because there are no downloads required. You don't even have to download Python in order to be able to use it. And it also really minimizes troubleshooting because it's in a web browser. You don't have to download anything. We don't have to work with different operating systems, different environments that our students might have. So we can just jump in and start coding. However, so when we started using Replit, it was completely free and open. You could just go to the website and start coding. And then in the past few months, they started to require a login. So it's still free, but does have that barrier of needing to create a username and password. We're still planning to use Replit because it is such a great and useful tool and really minimizes the need for troubleshooting and downloads. However, in the last class we taught, I did offer an alternative of pythonsandbox.com. It has limited functionality and couldn't support everything that we do in the class, but it was good enough and didn't require a login. And it seemed to work well having the two options so that our students could choose if they wanted to create a new username and password or just do the majority of the exercises in the Python sandbox. And I want to share a bit of our feedback from attendees. So we send out a survey at the end of each class, and we found that most of our attendees prefer the webinar format over in person. So I have this chart at the bottom, and it shows that about 55% of our survey respondents said that they prefer a webinar format, about 8% preferred in person, and 36% said either format is fine. So we take this to mean that our webinars are working pretty well for our audience. And we also received some mixed feedback on the IDE. So some really liked Replit and using the browser-based IDE. Others wanted to know more about coding in different environments and IDEs that they can use downloaded onto their computer. So we actually created a new class, an IDE overview class, to compare some different popular IDEs and do some demos. And we created some materials from this class that we can send out to our Python attendees just to provide some assistance in choosing IDEs and kind of introducing the coding environments beyond Replit that we use. And on the instructor side, we do plan to continue teaching online. So some of the things that we like about the online classes are that we're not limited by how many seats are in a classroom. We can have space for everyone in the online environment. And we've seen that the interest remains high and demand remains high as well. As we keep offering virtual classes, people keep attending them. So it's something that we're going to continue to offer even as in-person activities resume on our campus. That being said, there are a few things that we're still working on and some areas where we can improve. So the first is Zoom fatigue. On the instructor side, it can really feel like we're just talking into a void sometimes, but the poll everywhere polls and interaction has really helped us see that there are people on the other side of the screen. So we've been able to make use of technology to help combat that. On the student side, it still is a big problem. And we've definitely seen a drop in attendance and participation from the beginning of a semester to the end of a semester. So maybe we'll just have to front load our workshops and teach them when students are fresh at the beginning of the year. But we'll see ways around that. We're also thinking about better ways to share longer and more complicated code, especially as we get into more intermediate classes that we're starting to create. We might need to go beyond the Zoom chat to share some of that code. We've been working on accessibility of our materials and just trying to be aware of the accessibility features of the technology we use. That's an area where I think we can always strive to do better. And we're also updating how we share our materials. When we started the virtual classes, we were sharing by email and using OneDrive, but we've been working to make the materials more accessible and put them on GitHub. And that is all I have. I'm happy to answer any questions.
Awesome, thank you so much. I was also a research data management librarian for a bit before my teaching position, so awesome to see a librarian here presenting. We have a couple questions in chat. Daniel is asking if you've used Discord for teaching.
So we have not used Discord for teaching. That's something I've looked into, but and might look into more for the intermediate classes, but thought that we didn't want to add a new technology on top of learning programming. So we've stuck with Zoom rather than asking for the new technology and creating a new login for something like Discord.
We've had similar conversations about Discord and Slack for our workshops. There's another question. Do you feel that doing all of the coding in the web IDE prevents learners from doing more things on their own, using their own machines? This is always the struggle deals with when working workshops.
Yeah, I've also had the same thought and the same struggle. So again, we have really been focusing on trying to minimize the troubleshooting. So sticking with the Zoom chat, using the web IDE can really help with that and just jump into practicing coding. But then we've also seen demand where some of our students and our learners want to learn other environments. So hopefully our IDE class and other materials will help And we'll, just keep offering demos kind of outside of the Python class, or the introductory Python class. And hopefully, that's okay with some of our learners.
Okay, there's a question about using open source software, whether or not you've considered using other open source software like Big Blue Button.
So I have not heard of Big Blue Button. I'll have to look into that. And is this referring to the IDE?
Presuming so, that it's using that instead of
Replit.
yeah, instead either Replit or Zoom or something.
Yeah, so
I think I've seen this before. Yeah, but sorry.
Okay. Yeah, so for the IDE, when we started using Replit, it was open. So we just ran into the issue of needing a login for the most recent workshop.
I think instead of Zoom. Yeah. For the sake of time, I'm going to proceed forward. It's hard because it's another thing. It's another account someone has to make. And if you have to support, like anything makes me have to all of a sudden be a DevOps or sysadmin for teaching, it's not going to happen. There's a couple other questions. Yeah, sorry.
Just a Big Blue Button. I will look into that. I haven't heard of it, but at our university, we have Zoom accounts already. So we knew that would not be a barrier.
Mm-hmm. There's a couple questions about if they use third-party packages in your workshops.
Not in the intro, no.
And then someone else is asking, he has students in China and Replit doesn't work over there because of the firewall. Do you have you run into this issue or have any alternatives?
We have not run into that issue, and I do not have alternatives. We do have the Python sandbox. I'm not sure if that, would go beyond the firewall, but that's something that we should look into thinking about accessibility. But we haven't heard that is an issue up to this point.
Coral said that they use Python everywhere. I also use it, and I have had a student in China use Python everywhere for my stuff. So that is a thing that can work. So awesome. Thank you so much for your talk.
Thank you.
I think we are about to move into our lightning talk zone. So first up, we have Chiin-Rui Tan talking about interdisciplinary education. So you can go ahead and take the thing, and I can stick around if there's other questions for other speakers or anyone. I can stick around a little bit after too, or a little after the top of the hour, if you want to stick around and ask some more questions in chat. But yeah, go ahead.
Hi. Oh, you can't see me, can you? No. Okay, great. You can see, you can hear.
Yep.
Okay,
good.
great. Hi, so welcome to this lightning talk, Interdisciplinary Education Case Studies Applying Python to the Humanities, Social Science and Arts. So my name is Chiin-Rui Tan. Don't worry, it's not pronounced how it looks. So, but you can just call me Chin, which is like the chin on your face. My pronouns are she, her. I present female, but I'm actually non-binary. And also just to mention, I am neurodivergent. I don't normally do lightning talks because I find it really difficult to not talk about everything that I want to say. So bear with me. I'm going to try my best. So I'm sorry if this is a bit fast, but it's visual. So hopefully you'll understand what's happening, even if I'm speaking a little bit too quickly for non-English fluent or native speakers. What I want you to take away, if there's anything you take away from what I talk about in the next 5 minutes, is that Python is really not just for STEM education. It is actually widely applicable across the curriculum. Hopefully the case studies will do that. Okay, so quickly, who am I? Because I don't think I know very many of you. So I'm a tech entrepreneur. I have 14 years experience innovating using data science technologies. The last thing I did before I moved into education was actually building the first artificial intelligence for the British government's Foreign Office when I was the head of data science there. How did I get into education? So I'm very privileged. I'm very lucky to have had a really incredibly privileged education, but actually at no point during my education was I ever given the opportunity to learn to code. And interesting enough, my brother, who's older, he did actually have the opportunity to learn computing at school, for example. So anyway, that's in a whole different talk. So, you know, I've upskilled myself, and then I started to upskill the community. There's again another talk for another day. So yeah, I was starting to do R, which turns to R Ladies Global. And then actually I decided to basically just take the jump, and I just wanted to upskill full-time and the next generation. So I basically have a tech, which is basically a social enterprise, to try and give kids the opportunities which I don't feel I necessarily had when I grew up. And also just mention that the case studies are basically from my startup work, not as a sales pitch because it's a passion project, but it's obviously stuff I can give you more insight into because I did them. Okay, so just a really quick background as to the tech enablers, or what I think are the tech enablers of this kind of interdisciplinarity opportunities. So I'm sure it's used now, computers, data. They've really advanced since this, which is what I grew up with. Happy to date myself there. But also advances in open source software, obviously particularly what I'm talking about is Python scientific computing and the sort of data science stack, but also in terms of tooling. So Jupyter Notebooks, which is what I use for all of my education, and I really highly recommend it. Okay, so let's get some case studies. So this is an example of using Python for geography. So this is Joe. He was 6 at the time. This is when that's me. That's trying to homeschool Joe during the UK's, I'm London based, by the way. So yeah, trying to homeschool Joe in the UK's 3rd lockdown earlier this year. So he just started learning to type actually when we had our first session. He was really into population data. So the 3rd session, I basically created this data science workflow. He actually, obviously he wouldn't be able to replicate it, but he actually understood how this worked, and how to customize it to create his own visualization of this particular custom data set. So effectively that was sort of using pandas, which is data analysis package, and plotly, which is for visualization, applying that to geography data. So that worked really well. An example of applying using Python for sociology was from this boot camp, which I did at this all-girls school for their 6th grade. And one of the things, one of the sessions which went really well was actually getting them to create their own social knowledge graphs using Network X, the Network X package, which is basically a graph theoretic package, and then visualizing with Matplotlib. And one of the teachers who'd never done coding before just thought it went so well that she actually bought me this packet of sweets. So I like putting that in there as a reminder that, you know, people appreciate one's effort. Okay, so using Python for art. This is something I did with a 9th grade class. So basically teaching them Pillow, which is an image processing library. So they create their own artworks or source them, and then using Python, I taught them how to create their own GIFs and animation. So, you know, artistic things with like vanishing points and so on and so forth. And they did other kind of themed GIFs, Halloween and Christmas and stuff. And then this is actually the same school with from the boot camp, but actually they asked for a toolkit for the teachers. So this is interesting. So this is actually a digital humanities toolkit. So basically I created these sort of data science workflows using these kind of packages for them to be able to analyze and visualize numeric information and text information, but for their subjects. So for example, they could do geopolitical mapping, core path mapping, and then make that into an interactive widget, or natural language processing, so sort of text analysis, and using machine learning models, not just for English text, but in this example, being able to analyze Spanish literature, and then look at the top nouns in that extract. And then, in terms of higher education case studies, because I don't really have time, I think I'm probably running out. I'm just going to point you to this data set, which is from an IEEE article I was invited to write a couple of months ago, which has 16 Python interdisciplinary humanities, social sciences and arts course references, and also I've hopefully helpfully labeled which kinds of computational data practices each of those 16 courses has, just to make it easier for reference. And that's it. Thank you very much.
Awesome, thank you. All right, question in here. We can do, I think we have time for like one question. Given that Python is expressed in the English language, do you think that young kids whose first tongue is different will have a harder time? Method such as the is in method, and if yes, do you know how to jump the barrier?
First time is different. I think, to be honest, I would think that is a really good question. I actually don't think I have taught anyone who isn't sort of at least kind of bilingual. I guess I would say, I guess a lot of it's kind of just around, it almost doesn't even matter that it's English, right? It's just kind of like showing them, you know, the cause and effect. So if you just keep kind of showing them different examples of, you know, different sort of code snippets and what sort of changes with the outcome, maybe that's one way around it. I know I think that one is a tricky one. But actually some of my, I have some French friends and they actually say that for them, like, it's actually much easier. They kind of just think of coding as like English, you know, like, because I was like, oh, should we do some like, you know, French, you know, sessions for like French speakers? And they're like, actually, you know, for them, their mindset is just like, when I'm coding, you know, it's English, so it's not. It actually, they said it would be more confusing. But yeah, I'm just shooting an answer. I'm not sure. Sorry.
I've seen some research on this. There's in some, if I'm remembering it correctly, don't at me if I'm reporting the research wrong, but it can be easier for students because the more you understand a lot of times in the syntax, learners will inject their own understanding from an English word wise to the syntax and the keywords and stuff. And when that's kind of removed, learners actually can perform better. And there's clearly other challenges. Anyhow, there is some academic research out there about this. Awesome, thank you so much. Let's go ahead and go into our next and final talk, Martian math with Kirby.
Okay, I think you can hear me now. I'll turn on.
We've got
I'm the guy with the hat now. So you can see my screen, everybody?
Yep.
Okay, thanks for letting me round out today. I'm going to paste a bunch of URLs to the chat. So that's a good reminder also that even though we're not saving the chat as part of the video, you can individually save this chat to your computer, right, personally. So when it's all over, those 3 dots at the bottom, right, you know, save the chat. I'm going to certainly do that. So my background, you'll find me in the Python community over at the EduSig mail list, you know, the part of the python.org are these discussion lists that ebb and flow in terms of how much they're used. But going back to the 90s, the space I kind of fill is complementary to the data science in that we don't out of math want to lose kind of pure Platonic geometry either. When we talk about right brain kind of visualization, it's not just plots, it's polyhedron, it's 3-dimensional graphs, you could call them. So I do a lot with Python and 3D graphics. You could call it going way back. One way I've used is to harness a ray tracer, free open source, and have Python write scene description language for the ray tracer. So in the foreground, you're using kind of regular Python, but you've got a lot of help to later visualize as well. And I do a lot of linkage between Python and geometry just through figurate numbers. In other words, square numbers, triangular numbers, stuff like that. But that goes on to become 3-dimensional numbers, you could call them, cuboctahedral numbers, so on. So we have to draw in 3D as well. Now, as far as background, right when COVID broke out, I was working for Coding with Kids. I was driving around town, going to different schools. They had a Python curriculum. When we all went virtual, I got to experiment a lot more and I got to play a lot more with Jupyter Notebooks as a primary curriculum delivery method. I created a GitHub account, and I can evolve the text in response to student feedback. I don't have to start with the text finished, and they can get polling. So the idea is a live textbook that we kind of write together, students and teacher. Here's the model. They also should have GitHub accounts. In terms of sharing code, it's not that we're all working together and doing pull requests, but there is a certain amount of background on how to use Git. I don't see a good way to do Python the way I want to do it without some of that. There are a lot of ecosystems that overlap. And in terms of IDEs, I encourage experimentation because my students are middle to high school, and I don't want them to feel like we're deciding for them all these things. So go out and try. And we talk about IDEs. I sample different ones and so forth. So the Martian math that I talk about here is contextualized. I call it a kind of a Silicon Forest math. And here I'll paste a couple of URLs and you can track this down later. As I was saying, I was going to store some stuff here on the chat window. There we go. Oops, new share. Don't want a new share. Okay, and so there's a lot of focus on three-dimensional graphics, as I say, but the Martian math part is that we introduce, say, another coordinate system that's quite alien. And remember, these are kids who are working with XYZ coordinates. They're learning Python in the context of doing what you would call ordinary XYZ geometry. And so we throw at them this alternative called quadrats, and we say, this is what the Martians are using. In other words, there's 4 basis vectors to the corners of a tetrahedron. And instead of 3 tuples, we have basically 4 tuple coordinates. And using that, we can get all whole number integer coordinates for closest packed spheres. So there's a lot of focus, as I was saying, on sphere packing and so forth. I call it Martian math because it is indeed rather different, but under the hood, it's something from American literature, synergetics. It's sort of latter-day New England transcendentalism, you could call it. So I work with literature teachers to find more of a home for this. In other words, computer science and science fiction. We make a bond with the literature teachers and we teach this stuff internal to literature so that we don't have to bother the math curriculum because they're very busy with standards, and the math teachers have a lot less freedom than the literature teachers. So that's where we're at right now. I guess that's the end of my talk for today.
Awesome, thank you so much. I think we have a couple questions here in chat. The question of, do you see that the sampling different IDEs always ends up being what you're teaching out of because of the monkey see, monkey do that novices go through?
Because of Zoom and so on, they don't see each other or their desktops until we all share. And I really encourage show and tell a lot. And that can be a shock because suddenly you're seeing another student's desktop and it's got Python, but it looks very nothing like yours. They're using PyCharm. I do introduce Replit and the cloud-based ways of doing things. I'm totally for that too. And I want them as a novice to treat me as kind of a tour guide. I take them all over the Python universe and show them this, that, and the other thing, including pandas, because with polyhedra, it's not either or. Polyhedra call out to be put into a data table. Each polyhedron gets a row, but then it's relational because every polyhedron explodes out into all these XYZ vertices that make it up, edges, corners. These stored relationally give you the basis for using SQL and not forgetting your information about polyhedra. So I'm not turning my back on data science. I just wanted to add that, but I'm complementary to it. We do use pandas. All right.
Right, thank
I
you.
hope you can follow up on all those links that I put in there. So I'm saving the chat here.
All right. Thank you so much to all of our speakers. Thank you all for attending and coming in and listening. This has been recorded and I believe it'll get posted up on YouTube at some point. I'm not sure their scale. I know it was fairly fast for some of ours, or some of the one at least last year. So yeah, let's see here. Kirby, if you want to turn off your screen share there, you're still sharing if you don't know. Awesome, thank you all so much. We will have this again next year, so be collecting cool stories and stuff. I know that the last in-person or the last in-person education summit that we had included some like hands-on like work time to get some open source projects up and running. I have always thought about doing that in Zoom, but there's just not enough Zoom time in the world. There's too much Zoom time. So I don't think we're going to do that. But if you've got an open source project and you could use some community help, stuff like that, please keep that in mind for next year and have a plan to propose a talk for us. If you email me and you want to attend the Trainer Summit tomorrow, just send me an email at wix1@lerner.edu and I will send you the Zoom link. I also registered too late to register for my own events, so yeah, just send me an email. I'll send you the Zoom link. Almost certainly we'll have some spots and stuff. So if there's other questions and speakers who've been able to stick around or other sort of items, I'm happy to have a chat or say thank you for coming and see you either tomorrow or next year. Yes, this is being recorded and it'll go onto YouTube with the PyCon channel at some point, probably sometime this week. So yeah, the Trainer Summit is sort of a twofold event. It is, you can follow me on Twitter. I talk a lot about sewing and Python, but LinkedIn also is where I have a unique name, so just search me and you'll find me in there. So the Trainer Summit is more for the, oh yeah, there is the Python Educator site. I design quilts. I sewed this thing behind me. So yeah, anyhow, the Trainer Summit is, so the Education Summit this is like the 9th something year, has always had this great representation for like the K through 12 plus higher ed crowd. And what was missing, I actually created the Trainer Summit last year because what was kind of missing was like the more professional training stuff, like the kind of work that Reuven does. That has always had some element in the education community, but it's got like pretty unique needs compared to the more traditional educational crowd. And so the Trainer Summit, if you look on the same page, you can see a little bit about the talks, but it's sort of twofold. One, sort of talking about the more industry training stuff, so it's more industry rather than education focused, but it's also there's also some talks about, I wanted sort of one place for all of the like COVID was hard talks to go. And so I funneled all of those talks in there. So it's going to be sort of like virtual training pro tips plus more industry kind of stuff. And yeah, there is a Python Educator Slack that I created a couple years ago. And you can join with the link that Daniel put in there. There's a bunch of channels for higher ed, for K through 12, for posting jobs, as well as questions and stuff, and sort of a resource dump. So there's lots of stuff in there. It's pretty light on traffic, except for times during like PyCon. So yeah. Any other chance of virtual aspect to the Trainer or Education Summit? There's an in-person. Yes, Coral. I actually really like the virtual stuff. So I have no problem either trying to run it hybrid or having a virtual talk component, because I know it's also hard as educators in the middle of the semester to travel for several days. So I will do my best to figure out how I can figure that out. I know that if someone needs to present, we can figure that out. I presented virtually in 2015 at the Education Summit, so I will keep that in mind. And it just depends on the PyCon organizers themselves for what they'll be able to support. Ways to get involved next year. Harass me on Twitter. I don't know. I sort of threw this together alone this year because it was just sort of hard to have time to coordinate with anyone. Yeah, there's a variety of ways to get involved for next year. I think as you see the PyCon 2022 stuff opening up, just send me an email or ping me on Twitter or whatever, and I can get you linked into the crew. All right, I'm going to stop the recording here.